Students, today we are going to start with linear programming problem, class plus 2, chapter number. Let us start with introduction to definition and terminology. Linear programming problem. A linear programming problem is one that is concerned with finding the optimal value. Optimal value means the maximum or minimum value of a linear function of several variables. And this linear function is called objective function, subject to the conditions that the variables are non-negative and satisfy a set of linear inequalities. And these linear inequalities are also called as linear constraints. Variables are sometimes called decision variables and are non-negative. Few important linear programming problems are diet problems, manufacturing problems, transportation problems, and allocation problems. First of all, we need to understand the feasible region or solution region. Students, you have studied in your previous class plus 1 the topic linear inequalities, where you used to plot the graphical solution of linear inequality. Okay, so feasible region is the solution generated by all the linear inequations given. So the feasible region is same here, the common region determined by all the constraints, including the non-negative constraints x greater than equal to 0 and y greater than equal to 0 of a linear programming problem is called the feasible region or solution region for the problem. In feasible region solution, points within and on the boundary of the feasible region represent the feasible solutions of the constraints, and any point which lies outside the feasible region is an infeasible solution. Optimal solution. Any point in the feasible region that gives the optimal value. What is optimal value? Either maximum or minimum value. Of what? Of the objective function is called an optimal solution. Theorem number 1. Let R be the feasible region for a linear programming problem and let Z is equal to AX plus BY is the objective function. When Z has an optimal value, means maximum or minimum value, where the variables X and Y are subject to constraints described by linear inequalities, then this optimal value must occur at a corner point or vertex of the feasible region. Okay, that if R is the feasible region for a linear programming problem and we are maximizing the objective function or minimizing the objective function, okay, subject to the variables X and Y, then the optimal value means the maximum or minimum value will be occurring at the corner point of the feasible region. Theorem number 2 says, let R be feasible region for a linear programming problem and let Z be the objective function. Now, two possibilities are there. Number 1, either your region is bounded. Number 2, either the region is unbounded. So, if R is bounded, then objective function Z has both maximum and minimum value on R, and each of these values will occur at the corner point of R. Okay, and if the feasible region is unbounded, then a maximum or minimum may not exist, means either one may exist and other one may not exist. However, if it exists, then it must occur at a corner point of R. Corner point method. For solving a linear programming problem, the method comprises of following steps. Number 1, find the feasible region of the linear programming problem and determine its corner points. Number 2, evaluate the objective function Z is equal to AX plus BY at each corner point. Let capital M and small m respectively be the largest and smallest value at these points. Number 3, if the feasible region is bounded, say, and we know in this case both maximum and minimum values will be occurring. So m and small m respectively are the maximum and minimum values of the objective function. And if the feasible region is unbounded, then capital M is the maximum value of the objective function if the open half plane determined by ax plus by. What is this ax plus by? This is z. Z is equal to ax plus by. You have to check this ax plus by greater than m, greater than the maximum value obtained. If this open half plane has no point in common with the feasible region, then m will be the maximum value, and otherwise the objective function has no maximum value. Similarly, small m is the minimum value of the objective function if the open half plane determined by ax plus by less than small m, means the minimum value, has no point in common with the feasible region. Otherwise, the objective function has no minimum value. Now, third case is also there. If two corner points of the feasible region are both optimal solutions of the same type, means you are getting at 2 points, you are getting the same maximum or same minimum values, that is both produce the same maximum or minimum value, then any point on that line segment joining these 2 points is also called optimal solution of same type. In this your inequality, if we put x and y both 0, then 0 less than equal to 4 means is satisfied and origin will be included in this case. So while shading, we will find this triangle that is in the first quadrant as the solution or feasible region. So now we will check our objective function z is equal to 3x plus 4y at all these 3 corner points to locate the maximum value. Now at O00 you find z is equal to 0. Place x and y both 0. Z will be 0. At A, that is 40, z will be 12, and at B 04 z will be equal to 16. Now you find you were supposed to find the maximum value and it is coming out at 04, that is z is equal to 16 is the maximum value. Hence maximum z is equal to 16, and which is occurring at x is equal to 0 and y is equal to 4.